Okay, here we go with our Esters nomenclature practice. We'll do this with structural diagrams and show all the reactants and products for these two reactions. The first one that we want to get through here is ethanol and ethanoic acid. So we need to draw those two reactions. So here's my ethanol. And then I'm going to draw my ethanoic acid, which is based upon ethane, and I'm going to put my carboxyl group here on the left so that the two are nice and close together so I can see which parts have to come off of it. I got to finish off, there's 4 on that, and so there we go. So there's our two reactants. To make these, to make the product here of our ester and water, again, remember the alcohol will lose the H, the carboxylic acid will lose the OH, and so those guys will form the H2O that we have. And then we just have to link the remaining parts. So you can see that we would have a bonding site here on the oxygen of our original ethanol. So I'll just draw that here. There's 1, 2, and then there's the O. Finish off all of my hydrogens. Okay, and so you can see why we call the alcohol fragment just an alkyl group now. All right, when we take a look at the ester linkage, all that's left on the one side of it is carbons and hydrogens, our original alkyl branches. For our ethanoic acid here, we have lost that OH, so we have a bonding site here. So I have a place to put it, and so it can just go on the other side of the O here, and then I just take a look at what remains. There's the 2 carbons, there's that double bond O carbonyl group that still remains, and then I just finish off all of the hydrogens. This carbon has 4, and so we're good there. To name this one now, remember that we had ethanol up here. Now you just have carbons and hydrogens with 2 carbons, so this becomes ethyl, since we named the alcohol fragment first. And then we have a 2-carbon acid fragment, okay, with only the double bond O on it now. We change the suffix, so our ethanoic acid now just becomes ethanoate. All right, and so there's the changes to the original parts from ethanol and ethanoic acid to ethyl and ethanoate. Okay, I hope that's making sense to you guys. We'll do another one here in just a moment, but this is a particular ester that you guys are all familiar with, especially from elementary school. This is that particular scent that is associated with that Elmer's white glue that some of you guys shouldn't have been eating but were. Okay, we had one more example that we want to get through here, and that is taking a look at butanol and methanoic acid. All right, all of our alcohols that we'll be dealing with in esterification should be primary alcohols in which the OH group is going to be on carbon 1. We're going to keep it nice and easy for you guys that way. Okay, but the 1 is still necessary here because I could put that hydroxyl group in many places in a butane molecule. Okay, so we'll draw these two reactants, and then we will do the condensation reaction, pull out the water, and link the alcohol to our carboxylic acid. So, butanol, we've got to draw that one in a structural diagram. And so that is going to be 4 carbons with the OH. I'll just put it on the right so it's nice and close to my other reactant. Just to save space and time here in this video, I'll just use the dashes to represent the H's here. And then we had methanoic acid, so I just have 1 carbon, so it must contain the double bond O and the OH, only 3 bonds, so don't forget that 4th bond for your H. All right, these have to produce water and an ester. And so remember, it is the hydrogen only from your alcohol, and it is the entire hydroxyl group from your acid that go to make your water. And then we just have our remaining fragments. So I always like to start with the alcohol. Draw it first because it's named first. It just keeps it straightforward for me. And then so there's the remaining O. Nothing has changed with respect to the hydrogens on your alcohol fragment. Okay, and so you have 1, 2, 3, 4, all with hydrogens. And so your butan 1-ol just becomes butyl. And then we have the second part. You have just the remnants here for your methanoic acid. And so there's just the carbon, double bond O, and the hydrogen there. And so what was methanoic acid no longer has the necessary hydroxyl to still remain an acid. And so this just becomes methan O8 for the remaining part. So this ester linkage, the single bond O with 2 carbon chains on either side, one from an alcohol, one from an acid, makes the overall ester, butyl methanoate. And this is one that you guys know, I mentioned in the last video with your Slurpees. All right, this is the scent of raspberries. And this is one that we would have likely been able to make if we were able to do these in the lab. So if you guys go on to chemistry and post-secondary, don't skip the ester lab because it is a lot of fun making these artificial scents and so on and so forth. All right, it's about 7 minutes into this video. We've got a couple more that we're going to do here, but I think that'll take a little bit longer than the time we have left here. And so one more video to go to finish off our examples.